can do it to a certain extent, but it's not. It's easy to see that, like AlphaZero can learn without any human data to be better at chess than any human very quickly, very, very quickly. We can also see that the human brain is really bad at focusing on multiple things at once. You can think, especially at least for me, I can think of one thing, potentially two things at once, but not more. And it's easy to see a computer doing a thousand things at once. So I think there is so easy to consider how machine intelligence could be superior in so many ways to a human brain, even though it's not today. But it's easy to see it's happening.
I don't think people think of these things as weaknesses. Like, a magician will know that we have a super strong bias to movement, and that's how they do sleight of hand, right? They'll make you look at one hand, and then they'll do the thing in the other hand, and then you're like, wow, did you do that? That is a bias and a bug of sorts that they're taking advantage of. And it's so easy to imagine that we could just tell an AI, don't have that bias.
I was thinking when you were talking about memory, why do you think we have such bad memory? If you think about the transformer architecture that can remember basically anything it's seen, why are we are also a neural network of some sort. Why are we so bad at memory?
I guess from an evolutionary kind of point of view, we don't really need to have a perfect recall, right?
Yeah, I guess there are probably things that you don't want to remember. So we probably have circuits that erase memory just because we don't want to remember everything.
I think human brain is actually very good at forgetting stuff.
Yes,
and that could actually be a feature, right?
Yeah, that's probably a feature because you probably need that to learn new knowledge.
Yes.
I had a project that never really came to fruition, which was very centered on either using a vector database or a latent space RAM. And what I really wanted the LLM to do was develop a sense of whether to save something there or not and what to erase actively. So it has a limited amount of space and something you talked about recently, put it there, and if it doesn't seem important anymore, take it away from there. And I think the human brain does that. And not only does it do that, I think it compresses it. So the conception you have of Tom, the cat in Tom and Jerry, is probably comprised of components. You don't have like a pixel recollection of it. You have a cat concept, a gray, a cartoon, and then you sort of put them together. And that's very space efficient. And that's why you can make mistakes, because it's not perfect, but it's also super efficient.
It's super funny as you were saying the characteristics of Tom. It's building it. Yeah. I was building it while you were saying it, and at the third item, it just popped up. Yeah, it's super fascinating to think about how the brain works.
So I'm trying to keep this kind of podcast not too long, but I would love to see, if we think a bit further ahead, what would be the perfect next step or the best next step for AI models? We know they're really good in knowledge today. No question about that. I hope you agree. Then we want to combine the reasoning, I guess, in some way. But it could be other things, like the modular kind of approach that you spoke about, Robert. I'm a big fan of Jan LeCun. I said it many times. He has this JEPA architecture, which I think is really awesome. We could go into that. But what do you think the best direction would be to improve intelligence in coming AI models? Jesper, if you were to start.
I think it's obvious to say that we should be doing what we think we will get ahead with the further. I think we should look at where we're standing. So it's obvious that scaling things works now. Yes. That's not a super good thing because it will take so much power and etc. So much power and resources.
It is getting limiting, right? Even though we have a fewer number of parameters and models that we have synapses in the human brain, and still the human brain requires like 10, 12 watts to operate, and the AI clusters to run the models of the day is like megawatts kind of power. So the power efficiency is really horrible.
Yes. Yeah, and the next thing we have, you already said, is we also have something else that we know works, and that's the sort of reinforcement style of learning that we know from AlphaGo, AlphaZero, and etc. So combining the two approaches, that seems to be the most fruitful way of going forward today, based on what we already know.
And for me, for 20 years ago, when I did my PhD, it was actually in reinforcement learning. I'm not convinced that reinforcement learning as a technique itself is perhaps the best way.
Probably it's suboptimal. It seems to be very, very slow in converging because,
Yes.
but it depends a little bit on if you do a process optimization or if you do like a goal optimization, because then it takes ages to get the signal.
But I think the concept of search that you have in reinforcement learning is something that's missing today. So if we add at least that concept, but then the question is, is the type of cumulative kind of reward, assignment really a good thing? I'm not sure, but at least having search is something that we're missing today, right?
Having search and some kind of incremental updating of the model through the search, I think that's what's needed now.
Really, we're talking about how can we speed up convergence, because what AlphaGo had was, first they had a heuristic for what the next best step was, and then you added Monte Carlo on top of it, and that improved performance. But it was still a very strong performer even without the tree search. It just got even better when you combine them. And you have two approaches. You have a sort of a brute force approach, or a broad, what do you call it? Not explore versus
Exploitation
exploitation versus exploration.